Okay, so I'm just doing part D here. I've brought in the previous part there just because we're still talking about 80 male Persian cats. This is still linked to these three parts. So it says 12 of the cats weigh more than X kilograms. Estimate the value of X, right? So this is an inverse normal question, but they don't give us the probability, they give us the number of cats. So I need to find out, well, what probability or what percentage of cats is the 12? What percentage is 12 out of 80? So what I need to do is do 12 out of 80 times 100. That's to find what percentage of the cats weigh more than this. And the answer to that is 12 over 80 times 100 times 100 is 15. Okay, nice. So that's exactly 15%. So now it's like saying 15% weigh more than what? So again, guys, nearly always normal distribution, draw the curve. So 15% is up here somewhere, something up here. And I shade in this value and it's about 0.15. The mean is 6.1. The standard deviation is 0.5. It's 0.15 because it's 15%, and it's up here because 15% weigh more than something, and this is little x. So the probability that x, big X, is greater than little x is equal to 0.15. How do I find little x? Well, it's inverse normal, but be super duper careful because in your calculator, even my super duper calculator, you have to put in this area here. Now there are some calculators that give you the left tail. Just make sure you figure it out for your own calculator. But this value, the calculator I'm going to do, you have to put in the area that's left of x, which in this case is 0.85. So when I do menu, probability, distributions, inverse normal, I don't put 0.15, I put 0.85, a mu of 6.1, and a standard deviation of 0.5. Press enter, and we get 6.61822. Hang on, get rid of that pink. 6.61822. 6.61822, or 6.62. Okay, that's the estimated value of x. Then part E, it says 10 of the cats are chosen at random. Find the probability that exactly one of them weighs over 6.25. Okay, so firstly, what is the probability that x is bigger than 6.25? So the probability that x is bigger than 6.25 is menu, probability, distributions, normal CDF. Lower bound now is 6.25 because I want bigger than 6.25. The upper bound, just do 9999999 because it's something massive. Then the mean is still 6.1 and the standard deviation is still 0.5. Press enter. 0.382089. 0.382089. Don't round it yet. 382089, don't round it yet. And now, they often do this, guys, they turn a normal distribution question into a binomial distribution. So now I'm going to bring in a new variable, let y, let's go with y, capital Y. Capital Y is a binomial distribution. There are 10 trials because we're taking 10 cats, and the probability of success is this, because this is the probability that they're over 6.25, so it's 0.382089. Find the probability that exactly one of them weighs over this. So I just need to find the probability that y is equal to 1. This is menu probability distributions binomial PDF, because it's exactly 1 that they want. Number of trials is 10. Probability of success is this thing here, this 0.382089. The x value is 1. Press enter. And this is it, 0.050176, 0.050176, or 0.0502 to 3 significant figures. All good. Right, that is question 4 finished.